Find the length of BC and give your answer correct to 3 distinct figures. As I've got a non-right angle triangle and I'm given 2 sides and the angle that encloses those 2 sides, I know I'm going to apply the cosine rule. When using the cosine rule to find a missing length, we always label the length we're finding as lowercase a. Hence, in this case, my base is going to be my lowercase a. If that's lowercase a, then directly opposite is always the capital A. In this case, they've already labelled that as capital A. The capital letter is always the angle. B and C make no difference. The capital letter is the angle. So this is capital B angle, therefore directly opposite the lowercase b. If this is capital C, my angle, therefore directly opposite is my lowercase c. Substituting into my cosine formula, well, a squared is what I'm finding, so I'm going to leave a squared alone on the left-hand side. On the right-hand side, b squared, or b for me is 8, so b squared will be 8 squared, plus c squared, c for me is 11, so c squared will be plus 11 squared, minus 2bc cos a. In between each of the letters, we know there's multiplication sign, so minus 2 multiplied by b, which in this case is 8, multiplied by c, which in this case is 11, multiplied by cos of capital A, well, cos capital A, my angle for A, is 72. Substituting everything on the right into my calculator, that leaves us with a squared is equal to 130.613009. That's a squared. As I want the length of a, opposite squared is the square root. So then I'm going to square root my 130.613 number. And that equals to 11.428,60486. As I'm asked to give my answer correct to 3 distinct figures. Well, 3 distinct figures is I start from the left and I count from the first non-zero digit from the left. Our first non-zero digit from the left is number 1. Once you start counting, you don't stop. So that's my first distinct figure. That's my second. That's my third. As I round to the 3 distinct figures, I now stop and draw a line to the right. The one to the right is called my decider. Is that 5 or more? In this case, no. So therefore, I'm going to round down. So my final answer, correct to 3 distinct figures, is 11.4. Part B, find the area of the triangle ABC. Give your answer correct to 3 distinct figures. Well, the area of a non-right angle triangle is a half AB sine C. All I need to have is 2 sides and the enclosed angle. Here I've got the 2 sides and the angle that encloses them, i.e. the angle between the 2 given sides, which is 72. Therefore, substituting into my formula, it's just simply going to be a half multiplied by one side, doesn't matter which one you use first, times 11, times the other side, in this case, 8, multiplied by sine of the enclosed angle, so sine of my enclosed angle, in this case 72. Substituting into a calculator, that gives an area of 41.846,48672. As we want to give our answer to 3 distinct figures, well, 3 distinct figures means we start from the left and we count from the first non-zero digit from the left. Our first non-zero digit from the left is number 4. Once you start counting, you don't stop. That's my first distinct figure. That's my second. That's my third. As I round to the 3 distinct figures, I now stop, draw a line to the right. That's called my decider. Is that 5 or more? In this case, no. So I just round down. So my area is 41.8. As my length is in centimetres, my area is going to be in centimetres squared.